Here's Mu again, the programming environment that's built from scratch without any dependencies. There's a space for defining functions on the left. There's a list of low-level primitives on the bottom left just for documentation. And there's a REPL on the right. When I perform computations at the REPL, I have the ability to drill down into them to understand or debug what the computer did. I also have the Turbo Pascal-like ability to run a designated main function, taking over the whole computer, not outside the environment. However, one problem I had until recently was that when I tried to run the same program at the REPL, it was really slow. Let me interrupt. And it's really slow because of the trace. Collecting the trace is time consuming, it takes up a lot of space. So I've been thinking about what to do about that. And here's what I have. Now, after my recent changes, the program is almost as fast at the REPL as it was without a trace. And the reason it's fast is that the trace depth is now much lower. It's only taking a small amount of information and saving it while it runs the computation. When I browse the trace, it eventually notices that it doesn't have information and it transparently recomputes the command at the REPL. And now you can see that the trace depth is now 5, where it was 4 before. It's only able to do this. Mu is able to do this only because it can be sure that there are no side effects from rerunning the computation. And it can only be sure that there are no side effects because the entire computation, the entire stack from the ground up, is designed to enumerate dependencies like the screen or the keyboard or disk, referential transparency on top of an imperative substrate, all the way up from machine code.